Welcome to our presentation on the Neuronal Tract Explorer, a clinically integrated interactive web application designed to transform neuroanatomy education.
Neuroanatomy is often complex and abstract. Many have neurophobia. Learning spinal cord tracts requires proper three-dimensional orientation. Static diagrams and didactic teaching often fail. Students end up with no spatial and clinical integration. We need a solution bridging this gap between basic anatomy and clinical neurology. Our objective was to develop a mobile-friendly educational tool that directly supports this integration and pilot test this.
We aim to create something that provides visual pathway understanding, provides progressive clinical scenario questions based on active recall, provide immediate feedback, and mobile-friendly self-directed learning.
To build this, we utilized an instructional design approach aligned with the AD framework. That is, analysis, design, development, implementation, and evaluation.
Technically, the Tract Explorer is a standalone, lightweight web application. It is built using a modern front-end stack featuring React, Vite, Tailwind CSS, and Zoostand for state management. To ensure rapid performance and eliminate back-end dependency, all core data, including tract definitions and clinical quizzes, are driven by static JSON models. We integrated SVG files using React SVG and D3.js to enable deep interactivity. The project brings several unique innovations to medical education. First, we use dynamic CSS stroke-offset animations along SVG paths. This visually simulates the flow of neural impulses from the periphery to the spinal cord and up into the brain. Second, we have progressively difficult clinically relevant quiz. It starts with anatomy and physiology concepts, progresses to clinical testing, and later to pathology and lesion localization.
Upon completion of predefined level, badges are issued. Sequentially, one acquires Neuro Explorer, Clinical Thinker, and Master of Tracts badges. Final certificates are awarded upon the completion of grouped ascending modules, descending tract modules. The impact on learners has been highly positive. This app guides students through a structured three-step flow. Watch the pathway, attempt the clinical question, and localize the deficit. We reduce cognitive load and apply multimedia learning theory. Gamified elements like progressive levels, Master of Tracts badges, and certificates sustain self-directed motivation.
The platform is highly scalable. It relies on a modular, layer-based architecture and a static, JSON-based content model. Therefore, educators can effortlessly add new neuroanatomy topics, pathways, and clinical challenges without needing back-end overhauls.
In terms of portability, the app is entirely browser accessible and supports progressive web app optimization. In our pilot testing, nearly 90% of students access the module via their smartphones, proving its immense value as a portable, anywhere, anytime revision tool.
Because there is no back-end server required, the app is incredibly resource and cost-efficient. It can be deployed on platforms like Vercel and managed via GitHub, utilizing open-source frameworks to keep maintenance costs near zero.
We are proud to share our successful achievements. The project presented in the e-Innovacia professional category. In a pilot evaluation of over 50 students, the application received a mean score of 4.58 out of 5 for user interface design and a 4.68 out of 5 for diagram effectiveness. Furthermore, 100% of students rated the anatomy explanations as good or excellent.
Sustainability is built into the project's DNA through Git version control and iterative updates. We have already utilized student feedback to refine animations, add PWA support, and smooth out interface transitions. The open-source-friendly codebase ensures long-term continuity.
The Neuronal Tract Explorer proves that by merging interactive visualization, active recall, and gamification in a scalable, mobile-friendly format, we can conquer neurophobia and empower the next generation of medical professionals. Thank you for watching. We invite you to scan the QR code or click the link in the description and explore the pathways yourself.
Thank you for your time. Happy learning